Welcome to the video, Chapter 10, Lesson 3, Area of Irregular Polygons. The lesson essential question, how can we find the area of a polygon on a grid? When dealing with area of irregular shapes, it's best to break down the irregular shape into shapes that you do know area formulas for. In this case, this weird shaped polygon would be a triangle on the left, a quadrilateral in the middle, and another triangle on the right. We could add these three areas together to equal the area of this whole grid. Okay, so in finding the area of each polygon in square units, the ultimate goal is to find the number of squares. And so these different shapes, these irregular polygons, are going to be a mixture of nice whole squares, but then also mixtures of half squares also. So we're just going to count them up. Here's one whole square, then two whole squares, so two wholes, plus, and 1, and 2, and 3, and 4, plus 4 whole squares counting by halves. I said and 1, and 2, and 3, and 4. So this particular shape ended up giving us 6 units squared. And we can do the same thing with the more simpler up top. This shape is and 1, and 2. It's 4 halves. So that part of the formula, or when we have these irregular pieces, can give us from the halves. So 2 unit squares. So if we count the number of halves, we can figure out the number of whole units. We can do the same thing with this last one here. There's only one nice whole, so one whole. But then if I continue to break down into halves, 1, 2, 3, 4, 5, 6. There are 6 halves, so 1 plus 3 is going to be 4 units squared. Let's take a look at this larger irregular polygon on the right. It has 17 whole squares, and if I count the number of halves, 1, 2, 3, 4, 5, 6, add in the 6 halves, that gives me 20 units squared. So the formula for area we can write down is going to be the number of whole squares plus half the number of the partials. So let me go ahead and actually write the word whole so we can make sure we know what this means. So it's the number of whole squares plus the number, half the number of the partials. So let's go ahead and do that with these 3 examples. Take a minute and draw all of the whole squares and identify the number of partials. Starting off pretty simple, number 1 was just 7 square units. Number 2 had 3 full whole squares, and then 1, 2, 3, 4 partials. So 3 plus the 4 halves is going to be 5 units squared. In this one here, number 3, 1, 2, 3, 4, 5 whole squares and 2 halves, so it's going to be 6 square units. Go ahead and do numbers 4, 5, 6, and 8, because if you look at 7 and 9, they are repeats. So please do 4, 5, 6, and 8. So number 4, 5, and 6 in blue are the whole squares, and in green are the halves. So there were 4 halves in number 4, 4 halves also in number 5, and only 3 in number 6. So please know that just because all the answers so far have been nice whole numbers, it does not have to end up being that way. Number 8, you can see that there are 8 whole squares and 6 halves. So just don't forget those wholes up there also. So 8 whole and 6 halves, 11 units squared. Now, of course, that's not always going to be a half. So from here, we're going to use the same concept where we're going to use that the area is going to equal the number of wholes plus half the number of the partials. But what I really need to do is change this equal sign to an approximately symbol because we are going to need to estimate the following areas. We're just going to be counting the number of wholes, multiplying the number of partials by half, and adding those two together. The tricky part about these problems will be making sure you don't miss any of the partials. So I'm just going to go ahead and start with the wholes first. In this one, 1, 2, 3, 4, 5. So I see 5 holes, and then there's 1, 2, 3, 4, 5, 6 partials. So it's 1/2 times the number of partials. So that's going to end up being 8 units squared. And please understand, we're not going to do this every single time, but that is an estimate or approximate. So number 2, 1, 2, 3, 4, 5, 6, 7 holes. Notice that I did not include this block here as a hole, because even though it looks like a hole, this little section right here gets cut off, so it's technically a partial. So what I'm going to do is count that as a partial here, and so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 partials. So plus 1/2 of the 10, or plus 5, it's going to be 12 units squared. So again, we just have to be very careful about making sure we're not missing our partials. And my suggestion, especially with the grid, is just to work your way left to right, top to bottom. Let's go ahead and take a look at these 2 examples. Take a minute and see if you agree with my 15 whole squares. The partials, 1, 2, 3, 4, 5, 6 partials. So again, this is an estimate of 18 square units. Number 4, I found 8 holes and 13 partials. So a lot more partials in this one. You have to be very careful. This one's a partial because of that corner. Don't forget that little piece up there, this little piece here. We just have to be really careful that we don't miss any of our partials, or else we're going to end up calculating a wrong answer. Last couple here, let's go ahead and give these an estimate. Checking your answers, I got 7 whole and 7 partials, so 10.5 units squared. 7 whole and 12 partials, so 13 units squared. 15 whole and 6 partials, so 18 units squared on these last 3 examples. So when we are calculating area of your regular polygons, please understand that the ultimate goal is to add all the separate little pieces together. But when we are using a grid, you just count the whole squares and the partial squares using this formula, adding the wholes and just estimating with half of the partials. Thanks for watching.